Marine Gurukul has launched a number of online modules to support the students in passing their competency exams. For more details, you may connect with us and write to us on the email ID on the screen, that is marinegurukul@gmail.com. Thank you. Hello, welcome to Marine Gurukul video series. We are pleased to present this video on calculations or tidal predictions by use of harmonic constants. We hope that you have already seen our earlier videos on tides, volume 1 to volume 6, especially volume 6, wherein an overview of the harmonic constants was shared. Now, first and foremost, when do we need to use this method of tidal prediction by use of harmonic constants? Now, for some secondary ports, when you go to Admiralty tables to fetch the details of the time differences, you may not have a suitable standard port. In such circumstances, the letter small p is given instead of time differences, and the only way a prediction can then be made is by use of harmonic constants. If the duration of the tide is less than 5 hours or greater than 7 hours, for which we do not have the tidal interpolation curves, and we are not allowed to extrapolate on either side, in such cases also the use of harmonic constants is the only option. And lastly, of course, if a question in the exam explicitly states the use of harmonic constant method, then of course we'll be bound by the requirement of the question. As we are all going to use scientific calculator now, the template to be used for calculation of tide or tidal prediction using harmonic constants has been simplified. We shall first share this template with you, and if you like it and find it convenient, please adopt this template. The template will have some distinct sections. Section 1 part will be where generic information is captured, like port, ATT number, date and time zone. Then another section where the mean level shall be computed, and the lines here are serial numbered 1, 2 and 3. We shall also be recording the time of tidal prediction as per the time required. Then we shall have a section where some information has to be picked from the tide tables, others are to be calculated, and they need to be calculated for each of the 4 harmonic constituents M2, S2, K1 and O1. Then we shall have a section where again some information shall come from the tide tables, others shall be calculated, but they are not based constituent wise, so there will be only one input out here. And once this template is completed, then here we have the final template using which we shall be able to obtain the height of tide. And we shall now learn how each of these spaces or how each of these information required in this template is to be obtained or computed and filled in here. We shall learn how to complete the template and obtain the height of tide by taking the example of a question from January 2024 Chief Mate Phase 1 MMD exam. Find the height of tide at 0800 local time on 19th April 1992 at Port Sultanpur. It's in ATT2 by simple harmonic method. So the first thing we'll do is we'll go to the geographical index at the back of the ATT, concerned ATT volume, in this case ATT volume 2. So we'll go to the geographical index wherein the ports are in alphabetical order, and geographical index would look something like this. Here we shall locate our port. Our port is Sultanpur, that's highlighted in the box out here. Against this we have the port number 4344, and now we shall fill up the following information. the port name out here, that is Sultanpur, ATT number out here 4344, and the date for which the prediction is required from the question, that is 19th April 1992. Now we go to part 3 of the concerned ATT volume, in our case volume 2, and obtain the following information and complete the template. When we go to part 3, the upper part of the page would look like this, and we'll have the ports listed in the serial order of their port number. The lower part of the same page, or the following page, sometimes it's on the next page, will have the seasonal corrections like this. Once we reach this page, we locate our port, which is 4344, and we find it here, Sultanpur. The first thing we complete is the time zone. And where is time zone going to be captured? Out here. Where do we get time zone from? Here is the time zone which is stated. The time zone is minus 0530. Next we complete line 1. Line 1 is this information, that is value of Z0. This could have also been obtained from table 6, but since we are already on part 3, might as well obtain from here. You can see here is the value of Z0, and we go down to our port number and we find that this value is 4.13. Same is captured here. Next we go to the seasonal corrections, and the seasonal corrections are given against the port number and the concerned month. So for us it's 4344 and month of April, and the seasonal correction for us is 0, and we capture the seasonal correction here as 0.0. Then we complete the line 5, that is the value of small g for all the 4 constituents, that is M2, S2, K2 and O1. Where are they listed? Now on this page here you have the 4 constituents M2, S2, K1 and O1, and these are the values of G. You can see this is the value of G for M2, this is the value of G for S2, K1 and O1. And all these values from here are captured in line number 5 here under the appropriate constituent. I hope you have understood how to complete the template till this point. Having completed line number 5, now we go to line number 10, which is also completed from part 3, the values of H for all the 4 harmonic constituents. And the value of H is listed just next to G in each of these cases. They are all being highlighted by the green arrow and the green box. You can see the value of H being highlighted for each of the constituents. And from these green boxes, these values are transferred to line 10. It's 2.12 for M2, then 0.82 for S2, 0.00 for K1, and 0.30 for O1. Now from this particular part itself, part 3, we shall complete line 17 for small f4. That is line 17 out here. There will be only single entry, and small f4 is here in part 3. So we pick up this value and it's 214. From here, this value is captured out here in the template. Then next is line 18, value of capital F4, and F4 is here next to small f4 is the capital F4, and we pick up that value, and this value is 0.024. It gets transferred and filled in as line 18. We'll complete the value of line 19, that is small f6. Small f6 is captured in the part 3 next to f4 out here, and we pick up this value and since there is no value listed here, the value shall be taken as 0. And next to small f6, we have the value of capital F6, which shall be captured in line number 20, and again that will be 0. So now what you see is all these boxes, that is line 1, line 2, time zone, line 5, line 10, line 17, 18, 19 and 20. All this information has been picked up from part 3 of the concerned ATT volume. So once you go to part 3, try and complete everything so that you don't have to go back and forth between the different parts. So once you practice this template and you go to part 3, try and complete everything that can be picked up from part 3. Having completed all the information that was to be picked up from part 3, now we go to table 7 of the Admiralty Tide tables for the month in question, and here we have gone to table 7, the page that covers the month of April 1992. Now here first we shall complete line 4, values of A for all the 4 harmonic constituents which shall be captured in this line out here. Now if you see in this table, we have the 4 harmonic constituents M2, S2, K1 and O1 for the month of April, and under each we have the values of capital A and capital F. Right now we'll be interested in only the value A. We go to the date of the question, that is 19th April, and against that we'll pick up the values of A, which are being now highlighted by the green boxes. And all these values are captured in the template in line number 4. That's 046 for M2, 349 for S2, 212 for K1 and 176 for O1. Next we complete line 9, values of F, and capture that in line number 9. We already know where to get the values of F from. The orange boxes are highlighting those values, and those values from orange boxes are transferred to line 9 of the template. 1.06 for M2, 1.09 for S2, 0.97 for K1 and 1.05 for O1. Now your attention is drawn to this note 4C of the ATT explanation of harmonic constant tables, which clearly says omit interpolation of F. So you can just do it with F and don't have to worry about FT. So omit interpolation of F, hence omit certain lines, which we have already done, and instead of FT you can directly use F. So we'll be using F in lieu of FT, and that is what is also given in note 4C of the ATT explanation. So this note has been captured here to remove any doubts or ambiguity in your minds. Having captured all the information that we had to pull out from the different tables, now we are ready to complete the remaining. We just have to use our scientific calculator. First thing you should do is complete line 3. And what is line 3? Line 3 is sum of line 1 and line 2, and I'm sure all of you agree it will be 4.130 or 4.13. Next we'll go to line 6, which is small p, rate of change of A, hourly rate of change of A. Now for our purpose, we can use this rate as constant, though it does change slightly, but we can every time use the same constant value. It will not impact the accuracy of the calculations. For M2, the rate will every time be taking 29.0. For S2, we'll take 30.0. For K1, we'll take 15.0. And for O1, we'll take 13.9 degrees per hour. So these values every time will remain constant. So you can remember these values, recall these values, and complete line 6 of the template. Next, please complete this space for the time for which tidal prediction is required from the question. In our case, it's 0800 hours. So here you can fill in the format that it is given, no issues. But next, when you go to line 7, where again the time has to be filled in, please pay attention. The time in line 7 is to be filled in decimals of hours rounded off to the second decimal place. So if our time was 18 hours 12 minutes, the time in line 7 should be filled up as 18.20. So in line 7, when you fill in the time, please make sure you fill the time in decimals of an hour rounded off to second decimal place. For us, the time is 0800 hours. So for us, the time will be 8.00, 8 decimal 00, 8 decimal 00, and 8 decimal 00. I hope it's clear to everyone. Next, we shall complete line 8 and fill in this value of theta. What is this value of theta equal to? Theta is equal to A, that is line 4, plus G, line 5, minus P, line 6, into T, line 7. So it's line 4 plus line 5 minus line 6 into line 7. You can use on your calculator exactly the same way. And theta is to be always positive. So if you get this result as negative, add 360 degrees to it to make it positive and round it off to a whole number. No decimals required. Round off to a whole number and always positive. So if you're getting a negative value, please add 360. So on the calculator, basically, you will be using these to fill up the value of theta here, and it is 284. How will you feed your calculator? You will feed it like this: 046 plus 110 minus 29 into 8, and you will get the result in negative. Add 360 to it and you will get 284. So simple use of calculator, just enter the way it is given here. Line 4 plus line 5 minus line 6 into line 7. You will get the result. Round off to a whole number. If it's coming in negative, add 360 to it to make it positive. And you can get these values for all the 4 constituents. They are on your screen. You can pause the video, calculate all the 4, check for yourself before you move further with the video. Next, we will complete line 11 only for columns M2 and S2. Line 11 is equal to H into F into sine theta. We know the value of H, value of F, and value of theta in the respective columns. So effectively, line 11 is nothing but line 10 into line 9 into sine of line 8. And this value is to be entered rounded off to 3 decimal places with the sign as obtained plus or minus. So line 11 values will have the sign and also rounded off to 3 decimal places, and we'll be using these 3 values out here. So if you have to enter in the calculator, how can you enter? 2.12 into 1.06 into sine of 284 equal to, you'll get some value. You'll get a negative value, and whatever you get, round off to 3 decimal places, enter it here. So minus 2.180. Exactly the same way you can execute and get the value here. Please pause the video, execute the steps, satisfy yourself, and then move on. Next, we go to line 12 and complete it. What is it? Line 12 is equal to H into F into cos theta. Again, We know where H is line 10, where F is line 9, where theta is line 8. Only thing is, in line 11 we had sine theta, in line 12 we have cos theta. So again the values have to be put with sign, rounded off to 3 decimal places. So round off to third decimal place, use the sign as obtained plus or minus. So using these values, you will again enter 2.12 into 1.06 into cos of 284, and you'll get this value plus 0.544. You can obtain the values for all the 4 constituents and put them in the appropriate slot. And now you have been able to complete line 12 as advised earlier. Please pause the video. Make sure you are able to effectively use your calculator. Once satisfied, continue further. Now we come to line 13. That's R sine R, capital R, into sine of small r. It's nothing but sum of line 11 under M2 and S2. So complete line 13, this part, it is nothing but sum of HF sine theta for column M2 and HF sine theta for column S2, and these are basically line 11 column M2 and line 11 column S2. You add the two values. That means you add these two values. Whatever you get with sine is filled in line 13 out here. Now complete line 14. Line 14 is nothing but sum of line 12 under M2 and line 12 under S2. So we just add them, these two values, and they give us line 14. And what do we call line 14? We call line 14 as capital R into cos of small r. Capital R into cos of small r is nothing but h into f into cos theta for M2 plus h into f into cos theta for S2. That is line 12 column M2 plus line 12 column S2. Now we complete the value of line 15, that is value of capital R, as follows. If we square R sine R and add square of R cos R, we get this expression which you can see on the screen here. From here, capital R square is taken out as common, leaving you with sine square R plus cos square R inside the bracket. And we know sine square theta plus cos square theta is 1. So this expression reduces to R square. And if we want the value of R, what do we need to do? We just need to take square root of this R square then and round it off to 3 decimal places. Thus, based on this discussion out here, what is the value of R equal to? It is square of line 13, that is R sine R, plus square of line 14, R cos R, and then taking the square root of the sum, we'll be able to get the value of R. So using these values, now on your calculator, what will you do? You will take 3.047 square plus 0.328 square, and whatever sum you get, take square root of that, and you will get this value here. Fill up that value of R in line 15. So now we are on to the last line of the template, that is line 16, that is to be completed. And line 16 shall be completed to find the value of small r as follows. Now this can be found by either sine inverse of r sine r upon r, in which r and r will cancel out, and sine inverse of sine r will leave you with the value of small r, which effectively is sine inverse of line 13 divided by line 15. Else it can also be obtained by cos inverse of r cos r upon r, which effectively is cos inverse of line 14 divided by line 15. What you need to remember here is that when you calculate this value of R, you need to just use the absolute values, only the values of line 13, 14 and 15. Disregard the sign. You will get the value of R which will be less than 90 degrees. To exactly know what it is in three-figure notation, we'll have to identify or decide in which quadrant R would lie. So for that it is important. So we'll be using these any two of the three out here and to get R. Now it is important that once we get the value of R, which is only the absolute value less than 90, it needs to be assigned the quadrant, for which we can review how the trigonometric ratios are in different quadrants. We know an angle over a horizon of 360 degrees is divided into 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3 and quadrant 4. From school, what we have learned is in quadrant 1, all the trigonometric ratios are positive. In quadrant number 2, sine only is positive and of course its reciprocal cosecant. So sine and cosecant are only positive, rest all are negative in quadrant 2. In quadrant 3, the tangent and its reciprocal cotangent are positive, rest all are negative. And in the fourth quadrant, cosine and secant are positive, rest all are negative. I'm sure you remember that in quadrant 1 all, in 2 sine, in 3 tangent, in 4 cosine, all sine, tan, cos. They are positive and of course the reciprocals are also positive. So now now you see the sign of R sine R, which is negative, is because of sine R being negative, because capital R is positive. R cos R is positive or negative based on the sign of cos R. So based on the signs out here, if both my R sine R and R cos R are positive, my R will be in quadrant 1. If only R sine R is positive and R cos R is negative, then it will be in quadrant 2, because in quadrant 2 only sine is positive. If both are negative, then it will be in quadrant 3. And if R cos R is positive and R sine R is negative, then it is in quadrant 4. Now once we identify the quadrant, then we can find out the value of R from the R that we have calculated. Actual value of R shall be rounded off to a whole number. And then if you find that the R is in quadrant 1, then whatever you have calculated on the calculator is the value of small r. If you find it to be in quadrant 2, then actual value of R will be 180 minus whatever is the calculated value. If you find it in quadrant 3, then it is 180 plus the calculated value. And if you find it in quadrant 4, it will be 360 degrees minus calculated value. In our case, R sine R is negative, R cos R is positive. So in our case, it is in fourth quadrant. So suppose we are using sine inverse expression. So what will we do? In our calculator, we'll feed 3.074, disregard the sign, 3.074 divided by R value of R 3.065, get the result and do the sine inverse. Whatever you get there, since you are in the fourth quadrant, it shall be, you'll have to subtract the obtained value from 360 to get the value of R. Please execute it and see that you are able to get 276. And this is how R would be determined. Hope it's clear to you all. Now, having completed the template, we can now get the height of tide. And in height of tide, we'll fill up these columns and we'll be picking up information from the template that we have completed. Now, mean level will come from line 3. You can see the same color boxes are used for ease of correlation. So mean level is picked up from here. It's 4.130. Next line we have HF cos theta for K1, column K1, which is nothing but line 12, column K1, and that information we know, we can see from here is 0.000. Likewise, we have HF cos theta for O1, that is line 12 again, but column O1, that is column O1 is minus 0.143. Then we go to next R cos R, which is line 14. From line 14, we pick up this value plus 0.328. And then we have to now pick up the calculator and calculate the next value, which is capital R square multiplied by capital F4 multiplied by cosine of 2R plus F4. What do you have to do on the calculator? First, pick up the value of R, that is plus 0.3065 in line 15, square it, then multiply by capital F4. Capital F4 is line 18.024. Then multiply by cosine, open the bracket after cosine, and there you feed in 2 into R, small r. Small r we have calculated is 276. So it is 2 into 276 plus small f4. Small f4 is 214, and close the bracket. So first you feed in R square multiplied by F capital 4 multiplied by cos, open the bracket, have 2R plus F4, close the bracket, and equals to, and will give you this correction. Please try it out and see that you are getting this value out here as plus 0.157. Exactly the same way, calculate the last one. It is R cube into F6 into cosine of 3R plus F6. So feed in the calculator the same way. R cube into F6 into cos, open the bracket, 3 times small r plus F6, close the bracket, and you will get this value out here, that is 0. Once you have filled in all these 6 values here, remember there are 6 of them here, do the algebraic addition, and that shall be the height of tide. And height of tide in this case at 0800 hours local time on 19th April 1992 at Sultanpur is 4.472 meters. Now we come to end of this video. Hope you find it useful. This has been prepared with a lot of effort based on a lot of requests that were received by us, and hope this video lives up to your expectations. Please do share it with your friends, subscribe to the channel, press the notification button for automatic update on our new releases. Thank you very much for watching Marine Gurukul video series. All the very best. Thank you.